Welcome back to Adam Tech Tips, and I'm going to show you this. So if we press Y, we're not pressing G anymore. Now we can walk on the ceilings, not only walls. Previously my tutorials cannot do that, and now we have a planet system. And of course everything went smoothly. We don't have any more problems with the weird axis looking around and such a thing. And we have a planet blueprints that we can enlarge, and we can increase the gravity range, as simple as that. So if we go into the planets again, we can walk here onto our first planet, and we can just walk onto our second planet, and we are on our second planet. And I show you this in Unreal 5.6, but actually we can also do it in 5.4. So let's get on with it. So last time our BPTPC Gravity 2 doesn't have any press Y yet, so I'm going to make another one like this. And once we have duplicated this, we can just put the Y to 0 and put the gravity directed Z to 1. So we are not going down anymore, and we're not going left anymore, we are going up. So we can put the bug key Y and just plug this in. Now, when we press Y, that is walking correctly, but it's wrong. See that our camera doesn't flip. So if we press G, you can see that our cameras are going up. That is correct. But when we on the ceiling, our camera stays. You can see here, our camera doesn't rotate at all. So it turns out the simple solution is not to use any right vector from the previous vector. Let's just delete this right vector, and rather than making our new right vector, let's use make rod from ZX. Somehow if you are using XZ, it's still not the correct thing. So we want make rod from ZX. So let's delete this. So the Z value is from our new up from gravity direction, and our forward vector is X. And let's give Unreal the space to calculate its own X axis for our pivot. And now we can press Y, and we can walk on the ceiling just fine. This is very essential to the planet system that we are going to create. Maybe just a little bit of recap. How do we figure this out for the camera? Essentially, we are not using the standard camera input anymore. We took that enhance input action look into a sequence. That sequence is rotating camera pivot. This camera pivot is separated between camera pivot left and right. So this one, left and right. So we can look left and right for the camera. And then this up and down is looking up and down for the camera. And we rotate it specifically on its spatial axis. So input action value X, which is most left and right, is only going to rotate left and right the cam pivot. And input action value Y, which is the up and down on the mouse, is going to the cam pivot up and down. We reset the relative location again. So basically we are just zeroing out any other axis other than the Z axis on the left and right, and we are zeroing the X and Z axis on the up and down axis. And we put a clamp so we cannot look past 90-degree. So we cannot look like this. We can only look from this side and maximum on this side. This is how we figure out anchor to the gravity. And who's hosting left and right is basically just cam pivot gravity, which run on event tick. We set the world location, and again, just using the up vector from gravity, make it a rotator like this from the forward vector. Yeah, you should watch the previous tutorial if you want to build this from scratch one by one, not just a recap like this. And that is just a better option. Go check out my previous tutorial if you haven't understood this. And we are going to build the planets. And how to make the planets? We just make it via a blueprint. So go ahead and right click in the empty space, we choose blueprint class, we choose actor, and name it BP Planet Gravity. This is going to be the point of our planet and the collision of our planet. And go ahead and open this. Let's wire things up. We are not going to do event graphs. We are going construction script. Construction script allow us to have our variables controlling and instantly updating our blueprints while in editor. So we don't have to play it on runtime or play the game. It will update directly. And of course, it's only going to be useful for constructions, how we make the mesh or we scale things up or anything really, but we cannot animate in the construction script. So delays and timelines are not available in the construction script. So let's go ahead and drag this construction script, and I'm going to make a sequence because we are going to have some other things. We drag this sequence and let's just add static mesh. I'm going to use spear, and I'm going to use this arcade editor spear. A little bit of why is this arcade editor spear has the most equal wireframe. It has equal vertices. Just for example, if we use other spear, it have unequal wireframe. See that it has a lot more denser vertices on the tip. So we are going to use arcade editor spear, but this arcade editor spear has a problem. So if we see the collision, this is not a spear collision, it is a convex. The player are going to walk on the collision, so here, not on the surface. So I need to edit this, but we cannot directly edit this because if we search for the arcade spear, and we can see that this arcade editor spear is inside the engine content. So if we make change in this folder, if I move to other computer or if I copy this project to other people, they are not going to see the edits. So we need to copy this into our third person character. Third person character is on this third person blueprints, and we just drag this into our blueprints folder and hit copy. And here we can freely edit this. We can just remove collision and add another collision, and spear of course is the best collision. Hit save and we can use arcade editor spear. Maybe let's just name it edited, and it should be edited here as well. If we hit compile, hit save, now we have our planet. We're not going to scale things up, so let's just scale using a variable. So hit plus right here, and I'm going to make a planet radius, switch to integer. I really like integer. That means we don't have any decimals, and we can just set relative scale 3D. But of course you can use this, but this just means we are going to see like it multiplies on the original scales. What I actually want to do is first get component bounds, get its radius, divide the planet radius to this. From here, we set the scale again. Let's set this to 10. So this is actually dividing the scale by its original scale. So what happened if we put it here, we can see that it acts like a real unit. So if we put 100 in and we put it on there on the 0, for example, yeah, duplicate this and move it 100 units to the right, it actually exactly on the right axis. So we can see the wireframe, see that. So if we move minus 100, we have a spear that correctly has the 100 units as its scales. Now it's exactly what it is. So if we have 200, that means it have 200 units as the diameter. So it's now correctly scaled. So let's comment this up. Planet radius, I'm going to make it black and I'm going to make it 100. And now that we have the surface, we need some kind of the gravity field. So we just add spear collision. We are going to set the spear radius directly. So set spear radius, and this radius is settings, another variable. So let's just duplicate this, but this is going to be the planet gravity range. We're going to add from this. So planet radius, hit add and plug this in. I'm pressing Q to auto align it so it looks tidy. And let's set hidden in game. I want a new variable, promote to variable called debug view. So if this debug view is on, we are not going to see this hidden in game. So this is going to be the planet gravity range by radius. Now we have the gravity range. Now we have a scale. Now we have the planet size and the gravity field around them. If we hit play, we cannot see the range. If we check the debug view, it is half the gravity field still visible. And that it is for our planet. We are going to make the player interacts with this planet. And how do player interact with these planets? We are actually going to use tags. So I'm going to add from the sequence here. So just for you information, any actor in our Unreal environment can have tags, and these tags is publicly available. If we are on just get tags like this, we can just get reference to self and we get tags and then clear. So we are going to just make a single tags like this, and then we add the tags. So reroute node, copy this and add. I usually just use string, and I'm going to add this planet gravity. That is how we make the tags to be read by our player. And we are essentially finished with our planet gravity. Let's go ahead edit our character. So in our character, we have an event tick that corrects our world rotation, and that is based on our gravity direction. So it checks every time and it corrects every time. But rather than switching gravity like this, of course, we need to change the gravity every time. So I'm just going to drag this out here, and I'm going to make a sequence, drag this out and hit a reroute node. And from our reroute node for each loop, because I want to detect all of the things that have planet gravity. So maybe from capsule component, get overlapping actors. Let's just search for any actors that we have. Let's get hashtag. So this node is miracle. And let's see if we have planet gravity tags. So this is just a way of me of not having to cast between planet gravity and the third person gravity. So we just communicate via these tags. So if we don't found any tags, our characters are not going to do anything. And then if we are detecting the tags, we are going to set gravity direction. Where should our gravity points at? Of course, from the position of our planet gravity. So let's get actor location. We need to point this into this. We can use a node called get unit direction. So this is going to be from and to. And to is our direction of the planet, and from is our self, reference to self, and get actor location. So we are getting the direction of which way the planet is directing us at. Beware, if the point is somehow too close, it's going to be less than 1, and that might cause us a problem. So I would like to just multiply it, maybe 2, yeah. And then we just normalize the factor. So if it's a little bit larger, it will normalize it to 1. Why? Because gravity direction needs factor direction. Factor direction is only can be one or either of the other. If the gravity is pointing to a little bit y and a little bit z, that means it's going to be 0.5 and 0.5 right here. It cannot be some other way. I hope you understand. Let's just wire this up, and maybe let's just comment this as change gravity direction from all of detected planet gravity, hit compile and hit save. And let's just try playing it. I hope it works. Let's press Y. And now we are walking on our new planets. It's very good, guys. Oop. Okay, now we are moving on our second planet. See, that's the tutorial that is finished. Or if you a little bit lazy to wire these things up, I have the link of my Trakteer page where you can actually buy this blueprint. I'm sorry, you have to buy this if you are lazy. Just under $5. It's under $5. It's very, very cheap. And okay, yeah, like the video, subscribe, hit the notification bell, And thank you for watching.